On February 20th, 1943, north of Kasserine Pass in Tunisia, German tank commanders witnessed something they couldn't explain. American Sherman tanks were moving across broken terrain with perfect coordination, without using any visible signals. 5 tanks advanced through dust and smoke as if they were connected by one mind. They had no flags, no flares, and no messengers. Yet every crew seemed to know exactly where the others were, covering each other's blind spots flawlessly. Meanwhile, German Panzer IVs, equipped with FUG-5 radios, struggled just to maintain contact. Their AM-based transmitters produced constant static, and the 10-watt signal barely reached a few hundred meters when the tanks were moving. Most German vehicles could only receive orders. They couldn't send messages or call for help. The Americans, however, were operating with a new kind of technology that the Germans didn't even know existed: frequency modulation radios. Every Sherman carried one, built with crystal-controlled precision, delivering 25 watts of power, strong enough to cut through engine noise and battlefield chaos with crystal clarity. 8,000 miles away on Detroit assembly lines, this invisible innovation was quietly reshaping modern warfare. The greatest advantage wasn't armor or firepower. It was communication. This leap forward began on July 22, 1941, when the U.S. Army standardized new signal corps radio sets, SCR 508, SCR 528, and SCR 538 for all medium tanks. At the time, German forces were sweeping through the Soviet Union using outdated AM radio systems. Meanwhile, American engineers at Galvin Manufacturing Company, which would later become Motorola, were perfecting FM technology for combat use. Daniel E. Noble envisioned how FM could revolutionize battlefield communication, while Henrik Magnusky engineered a way to make it durable enough to survive inside a tank. Their work produced a 181-pound system that turned every Sherman into part of the world's first battlefield radio network. The BC 604 transmitter provided 25 watts of power, more than double the German FUG-5, and operated in the 20.0 to 27.9 MHz range with 10 preset crystal control channels. The dual BC 603 receivers in the SCR 508 allowed commanders to listen to multiple frequencies at once, a capability that proved critical in combat. The true game changer, though, was FM itself. Developed by Edwin Armstrong and licensed to the U.S. military, FM eliminated the static and interference that crippled AM radios. While German crews heard constant electrical noise, American tank crews could speak clearly even during heavy artillery fire. When U.S. armor landed in North Africa during Operation Torch on November 8, 1942, this new system showed its full power. The 2nd Armored Division's tanks, fitted with SCR 508 radios, quickly proved far more coordinated and responsive than the German Afrika Korps. In a typical German tank platoon of 5 vehicles, only 1 or 2 had full transceivers capable of both sending and receiving messages. The rest had receivers only. They could hear orders but couldn't reply or report what they saw. This rigid communication structure meant that if the command tank was destroyed, easy to spot by its multiple antennas, the entire unit lost coordination. For the Americans, every tank could take command if needed. That flexibility, made possible by superior communication, gave U.S. armored forces a decisive edge over even the most experienced German crews. The Battle of Kasserine Pass, fought from February 14th to 24th, 1943, became the first real test of America's new radio technology, and the results stunned German observers. Although the Germans won the battle on the ground, they realized they were facing a new kind of threat in the airwaves. Even in the chaos of combat, scattered groups from the U.S. 1st Armored Division managed to stay coordinated across more than 50 miles of battlefield. Crews who had never met were able to warn each other of ambushes, request artillery fire, and launch joint attacks, all through crystal-clear FM communication. German intelligence units listening in were shocked. They noted how American transmission stayed strong and clear at distances where German radios could only produce static. The 10th Panzer Division reported that every U.S. tank appeared capable of full radio transmission, not just command vehicles. By comparison, the German FUG-5 radios, operating on amplitude modulation in the 27 to to 33 megahertz range, were limited by design. Their 10-watt transmitters could barely reach 2 or 3 kilometers under perfect conditions, and much less when the tanks were moving. Electrical noise from engines and spark plugs overwhelmed the signal, making communication unreliable and often impossible. By September 1943, American tanks had moved into Italy. The mountainous terrain should have made radio communication even harder, but it didn't. FM technology actually performed better in valleys and ridgelines where German AM systems failed completely. The SCR 508 radios filtered out echoes and signal distortion, allowing American crews to coordinate in places where no visual contact was possible. During the push toward Cassino, U.S. armored platoons separated by mountains and ridges carried out perfectly timed maneuvers that German doctrine said were impossible without line of sight. Reports from the 1st Armored Division later described smooth coordination at distances where German equipment delivered nothing but static. Then came June 6, 1944, D-Day. As American tanks rolled off landing craft at Normandy, their SCR 508 radios kept them in contact with naval gunfire teams, something German forces could not match. But the invasion also exposed a weakness. Tank radios couldn't talk to infantry units because they operated on different frequencies. The tanks on 20 to 27.9 megahertz, and the infantry's SCR 300 radios on 40 to 48 megahertz. This mismatch proved deadly in the dense hedgerows of Normandy, where German soldiers armed with Panzerfaust could sneak close to American tanks, while nearby infantry had no way to warn them. Within weeks, American engineers found a solution. Tank crews began attaching EE-8 field telephones in metal boxes on the outside of their vehicles, wired directly to their internal systems. By the time Operation Cobra began in late July, this simple fix had transformed tank infantry teamwork. From July 25th to 30th, 1944, Operation Cobra showed just how far American communication had come. Under Major General Edward H. Brooks, the U.S. 2nd Armored Division coordinated more than 200 Sherman tanks through radio networks that gave commanders precise control over fast-moving battles. German forces from a Panzer division were caught off guard by an opponent that seemed to react instantly. American tanks received and shared reports across miles, directing artillery strikes that landed within minutes. In contrast, German coordination had collapsed. Most of their tanks no longer had working radios and had to rely on hand signals in terrain where they could barely see 100 meters ahead. Those few radios that still worked suffered from static, weak range, and interference, leaving the once elite Panzer Division nearly blind on the battlefield. The irony couldn't have been greater. Germany had been the pioneer of using radios in armored warfare. Heinz Guderian, the architect of Blitzkrieg, had insisted that every tank should carry radio equipment as far back as the 1920s. In his 1937 book Achtung Panzer, he emphasized that communication was the heart of mobile warfare. Guderian personally helped design systems that allowed tank officers to coordinate movements and attacks. He knew that fast-moving armor was only as effective as its ability to communicate. But by 1943, Germany's production lines could no longer keep up with his own vision. The numbers told the story. That year, Germany built around 5,700 medium tanks, but produced fewer than 2,000 FUG transceivers. Most of those radios went to command vehicles or assault guns, leaving regular tank crews without the communication tools they desperately needed. The Soviet Union faced an even worse situation. The T-34, though one of the most widely built tanks of the war, often entered battle without any radio at all. Soviet tactics relied on flags and prearranged plans, which led to chaos and heavy losses against the Germans in 1941. Later, U.S. Lend-Lease aid helped fill some of the gap, delivering American-made SCR 508 radios for Soviet command tanks. But by the end of the war, only about a quarter of all Soviet tanks were radio-equipped. This contrast highlighted America's remarkable achievement. While the Soviets were struggling to equip even a fraction of their forces, the United States managed to outfit every single Sherman tank with advanced FM communication systems. At Motorola's Chicago plant, American industry reached a level of efficiency that few could match. Before the war, the company made car radios. When production shifted to military needs, the entire factory had to be redesigned and retooled from the ground up. Building each SCR 508 required 2,748 separate components crafted with precision. The BC 604 transmitter alone contained 474 capacitors and 385 resistors, while the crystal oscillators had to hold perfect frequency even under intense heat, vibration, and shock. Production ramped up at an incredible pace. 3,800 units in 1942, 11,400 in 1943, and 24,000 in 1944. By the war's end, over 50,000 tank radio sets had been produced, enough to equip all 49,324 Sherman tanks built during the conflict. No other nation came close to that level of consistency or scale. The SCR 508's advantages went far beyond FM clarity. Its crystal-controlled frequency system meant that channels could be preset before battle and remain perfectly stable throughout combat. German Fug 5 radios, by contrast, used manual tuning that constantly drifted off frequency, forcing operators to readjust during fighting. Each American tank also carried 2 receivers, letting commanders monitor both their platoon and company communications at once. This allowed orders to move quickly down the chain of command while giving leaders a full picture of what was happening across the battlefield. Inside the tank, the BC 606 intercom connected every crew member directly. Throat microphones and noise-canceling headsets allowed clear communication even under heavy fire. Many German tanks had no intercom at all. Crews had to shout or tap one another to pass instructions. The SCR 508 also managed power more intelligently. It could run on either 12 or 24 volts and automatically adjusted to whatever was available. A specialized dynamo motor stabilized the current and filtered out electrical noise, keeping transmissions clean. German radios, drawing power straight from the tank's electrical system, picked up every spark and fluctuation as static. This universal communication system reshaped how American armored forces fought. The flexible combat command structure, task forces built and reorganized for specific missions, was only possible because of reliable radio coordination. Commanders could combine tanks, infantry, and artillery into new formations on the fly, confident that every unit would stay in contact through their synchronized, high-performance radio networks. This level of flexibility completely confused German commanders, who were used to rigid structures made necessary by their limited communication systems. In September 1944, during the Battle of Erwin, the U.S. 4th Armored Division went up against several German Panzer brigades equipped with the more powerful Panther tanks. On paper, the Germans had the clear advantage in armor and firepower, but once again, American coordination through superior radio networks decided the outcome. Every Sherman tank could instantly report enemy locations. Tank destroyers received target data from tanks beyond their line of sight, and artillery observers inside command tanks called in precise barges within minutes. Over 3 weeks of fighting, the 4th Armored Division destroyed 281 German armored vehicles while losing just 41 Shermans, a staggering 7-to-1 kill ratio that defied expectations. Yet German intelligence never fully understood what they were facing. Reports often mentioned the impressive coordination of American tank units, but wrongly credited it to discipline and training instead of technology. A captured German assessment from September 1944 even stated, "American tank units demonstrate good radio discipline and coordination." This appears to result from extensive training and rigid communication procedures. The report completely missed that U.S. tanks were operating with far superior radio systems. Because of this misunderstanding, German tactics never evolved. They continued to focus on destroying command tanks, based on antenna configurations, unaware that every American tank could serve as a command unit. They planned ambushes assuming American formations would fall apart once separated, but didn't realize radio contact kept them unified even without visual sight. By March 1945, as American forces approached the Rhine, this communication superiority reached its peak. The capture of the Ludendorff Bridge at Remagen showed how fast American command and control had become. When the 9th Armored Division discovered the bridge still standing, their radio report reached 1st Army headquarters within minutes. Within an hour, entire divisions were already repositioning to take advantage of the opportunity. German units, relying on telephone lines that had been destroyed by Allied aircraft, couldn't react fast enough. American radio coordination built a near-impenetrable defense around the bridgehead. Tank platoons from different battalions operated together seamlessly, directing fire through shared radio channels. German counterattacks, poorly coordinated and arriving piecemeal, were quickly wiped out. A month later, in April 1945, the encirclement of the Ruhr Pocket marked the final stage of American communication dominance. Armored columns from the U.S., 1st and 9th Armies coordinated an intricate double envelopment entirely by radio. Inside the pocket, 325,000 German soldiers were trapped as their own communication network collapsed. Allied fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed what remained of German command links. Wehrmacht units lost all contact with headquarters and neighboring formations. Field Marshal Walter Model's final messages before total radio silence told the grim story. No contact with nearby units, no communication with higher command, fighting continuing but no coordination possible. For American crews, this technological edge changed the entire experience of tank warfare. Even when separated or cut off, they knew they were never truly alone, always connected by radio to their comrades. German crews, however, fought in near total isolation. Without reliable communication, they battled as individuals rather than as parts of a unified force. Otto Carius, one of Germany's top tank commanders, later wrote in Tigers in the Mud about the immense difficulty of operating with limited communication. Though he focused on tactics, his experiences reflected the same core problem: Germany's lack of reliable battlefield connectivity. By 1944 and 1945, the strategic effects were undeniable. American advances across France and into Germany maintained constant momentum because of their radio networks. Patton's Third Army, in particular, relied on these systems to control fast-moving units spread across hundreds of miles. German leaders consistently underestimated this advantage because they couldn't imagine how far American communication technology had evolved. Even Heinz Guderian, serving as Inspector General of Armored Troops, recognized the crisis, but by then it was too late to fix. In December 1944, Heinz Guderian himself finally admitted what many German commanders had begun to realize. The Americans' ability to coordinate so effectively on the battlefield had erased Germany's advantage in tank design and firepower. After the war, U.S. technical intelligence teams examined captured German equipment, confirming what frontline soldiers already knew. German tanks were often stronger and better armed, but their communication systems lagged far behind. According to U.S. Army Technical Intelligence Report Number 176, German tank radios were roughly 5 years behind American technology. The lack of frequency modulation, the shortage of radios across units, and poor electrical shielding created fatal weaknesses that no amount of armor could offset. Soviet analysts reached the same conclusion. After testing captured German gear, they chose to model their post-war radios on American designs rather than German ones. Production numbers revealed the true scale of America's accomplishment. More than 50,000 SCR 508, 528, and 538 radios were produced, enough for every one of 49,324 Sherman tanks built during the war. That meant full deployment across all armored forces. Each radio delivered 25 watts of power with crystal control frequency stability within plus or minus 0.01%, and an effective range of up to 7 miles while moving in 10 to 15 miles when stationary. Germany's record was far different. Only about 6,000 FUG-5 transceivers were built to serve roughly 12,000 medium and heavy tanks, meaning just 20% of vehicles had two-way communication. Their 10-watt transmitters had variable tuning with plus or minus 1% frequency drift, and could typically reach only 0.5 to 1 mile on the move or 2 to 3 miles when stationary. The performance gap was enormous. American units could call an artillery within 3 to 5 minutes. German requests took 15 to 30 minutes on average. Nearly all U.S. tanks operated in constant coordination, while only 1/5 of German armor could communicate effectively. This edge in communication shaped the future of armored warfare. The principles behind the SCR-508, universal radio deployment, stable connections, and reliable coordination, became the foundation of modern tank communications. Today's main battle tanks use digital systems, but the core concept is the same. Every vehicle must be networked and able to share information instantly. When West Germany rebuilt its army in the 1950s, it applied these hard lessons. Every Leopard tank was fitted with a complete communication suite. A Bundeswehr training manual summed it up perfectly. Asterisk, to defeat a superior German tanks by inferior American vehicles with superior radios proves that information dominance outweighs platform superiority. Asterisk, that truth has only grown clearer in modern times. In the 1991 Gulf War, coalition forces equipped with advanced communication networks crushed Iraqi armored units operating Soviet-designed tanks that were powerful but poorly connected. The same held true in 2003, when American forces again showed that network-centric warfare consistently outperforms raw hardware strength. The story of the Sherman's radio isn't just about engineering. It marks a turning point in military history. It was a victory fought and won in the electromagnetic spectrum, where communication and coordination matter more than the thickness of steel or the size of a gun. German tank crews fought much of the war unaware that they were facing something entirely new, a form of warfare powered by invisible connections. They learned too late that every American Sherman tank wasn't just a vehicle, but part of history's first true battlefield network. The SCR-508 radio had transformed the M4 Sherman from a simple medium tank into one link in a massive, coordinated war machine. That change proved more decisive than any improvement in gun power or armor ever could. Each Sherman carried not only its 75mm cannon, but also 181 pounds of advanced radio equipment that linked it instantly to every other American tank on the battlefield. This connection created a kind of shared intelligence, a coordinated awareness no single German tank, no matter how well built, could match. German forces realized this the hard way. From North Africa's Kasserine Pass to Italy's mountains, across France's hedgerows, and into Germany's final defenses, American tanks moved and struck with precision that defied German expectations. Their doctrine said such coordination was impossible without direct visual contact, but the Americans proved otherwise to the power of radio. The Wehrmacht never developed a countermeasure because they never fully grasped the scale of their disadvantage. Field Marshal Wilhelm Keitel reportedly summarized it at Germany's surrender. Asterisk, we knew how to build better tanks, but you knew how to make them work together. Asterisk, whether or not he actually said it. The statement captured a profound truth. America hadn't just built 49,324 Sherman tanks. It built 49,324 connected units in a single, integrated combat network. The revolution in warfare that modern militaries now call network-centric combat didn't begin in the digital age. It began in 1942, when the first Sherman tank equipped with an SCR-508 radio rolled into battle. From that point forward, the balance of power shifted. The side with better communication would defeat the side with better weapons. Networks would beat platforms. The connected would overcome the isolated. For the Germans, this transformation was almost invisible. They saw American coordination on the battlefield, but failed to understand the technology behind it until it was far too late. By the time they realized that every Sherman had reliable radio communication, while most of their own tanks did not, the war was already lost. This failure to recognize and adapt to America's communication edge became one of World War II's greatest intelligence mistakes. Despite repeated encounters that showcased U.S. coordination, German leaders continued focusing on producing heavier, more powerful tanks rather than solving their communication shortfall. Their machines were impressive, but they fought as isolated individuals, while American tanks operated as a single, unified system. In the end, it wasn't just steel or firepower that won battles. It was the electromagnetic waves transmitted by the SCR-508, the ability to share information instantly, to coordinate across distances, to fight as a team rather than as scattered units. This invisible advantage proved stronger than even the German 88mm gun. The Sherman's radio superiority forever changed modern warfare. It cemented one lasting truth. In battle, Connection means survival, and isolation means defeat. German troops learned that lesson across 3 continents, discovering too late that the Americans didn't just have more tanks. They had a smarter, more connected army built for a new era of war.